music. Where is my music? I need a new algorithm. What is a good algorithm? Well, if you have something like this, the only thing I tried was moving a single element to another group. Or move the whole thing to another group. What about moving what about moving more than one but less than everything? That's a lot to do brute force. This one has already 14 elements. And that's 14 faculty possibilities. Where's my calculator? As if it... I don't know that it is a big number. Where it is. Not enough light to find my faculty. It's big. 87 billion. Not going to do that brute force, so we would have to try a subset. Interesting thing of this thing is that if you just try only these elements, they probably want to be all together. Okay, let's just start playing a little bit. I want to know the... well, actually, let me see the... it's too much. Let me see the solution. This is the solution. At least we hope so. Oh, okay. For example, here we have a group A, C, D, Q, X, Y. So that in order to get this group, I would have to remove certain things from this group, but also add X. And the X comes from here, which group looks a lot like this one. None. No, more or less. Oh yeah, this one. UTJR. So wait a minute. There's a bug. I see E in many. Ah, damn it. Why didn't I see that sooner? This is not working at all. Is that related to me trying 26? This one worked. That's interesting. Both have the same score. Oh yeah, it's totally broken. So we end up with something with already with two members. I end up with a group with B in two different sets. Actually, I keep confusing this thing. We end up with a partition with B in two different, and I call them groups, and sometimes sets. No, why? And what is this? Oh, that is 10,000 temps. Well, then we have something that is horribly broken. Let's figure out exactly where that bug is before I go to bed, okay? Then instead of 10,000, I probably should try 10 or so. Okay, still get the same thing. Yeah, the reason these two partitions between very fat double quotes have the same score is because if you put A and B together in a group, it gives a score of 5. So this one has a true score of 5, and this one has also an AB, and that one is a score of 0, so also a score of 5. But of course it should never be 2 Bs. Where does that come from? One possibility is that my random partition generator is broken. I guess I'll just have to print them again. I really don't care about the score. Current partition. Initial partition. I know. Yep, that's broken. Well, that's not good. I thought it worked. I was convinced it worked. Actually, I just know it worked. And now suddenly it doesn't work anymore. Well, the random partition generator depends on a seed. Depends on random numbers. We'll have to begin with turning on the debug output again so we can see the seed, or maybe the seed was already hard-coded. Well, debug doesn't hurt. Maybe it worked on the debug and it broke on the release. And I did. This is all exactly correct. Now we have just A and B separate or together, and no duplicates. So this refuses to tell me that there is uninitialized memory being used, but that should be the case. Okay, let's make this rel of the debug. I had a problem yesterday or 2 days ago too. What was it then? An uninitialized standard array. uninitialized, indeed. Again, instanted sort. And well, called from sorts, from who cares, sort. Looks like the same thing. The same bug. I thought I fixed it. And this time is from random. Maybe it's a little bit different. Let's have a look here. Random initializes a partition top from a group which is initialized from an element which is named by its name as a character. And now nobody knows when the sort is being called. Oh, seriously, the element cannot go wrong. Element is explicit char, just as index to bit from name to index. Name to index is name is a minus a is 0, cast to an element index POD, which happens to be a bit set. POD, which is that. Well, I guess accurate initialization. This should end up as a 0. Is that true? Looks weird to me. Let's do it like this. Oh, don't even need that, I think. The problem was in narrowing something. So I need a static cast, but for the int 8 type. I just want to keep it a character, even though the subtraction turns it to an int and then starts to complain. Offline, this is related to the Vulkan engine. Yeah, theoretically, I'm working on an algorithm to find out how to distribute shader resources over descriptor indexes, scripter sets. I mean. But I try not to think about that when I'm working on a certain problem. I'll get back to that once this works. Okay, we have here I think this should work better. Now the index POD can be passed through an element index, which elements type index, which is of course what? Well, it's a bit set index. Okay, let's make C tags. Sorry, I was here. Name to index. Name to index. Now it should absolutely definitely call element index from the index POD, which has an element 0. So that is elements type index, which is just bit set index. Oh, it was already on. Which is a constructor from the POD, which just assigns its own index from there. It's definitely totally working. It's possible that it will not work. Well, I'm checking it anyway. So then we have an element index, and then we convert that to index to bit, which you just shift it. Must work as well. Okay, so we have an element, and then construct from that a group. Elements is again bit set. Yeah, well, that will work. Should work, really. Just I don't see an array. Let's put it that way. Partition is being constructed from a group then, and that would be this one. Well, we just pass a single group, so m groups is past a single group. That's not working. I think this is the bug. Strangely enough, if you initialize an array with a like this, you just pass the first element, then the remaining elements might or might not be zeroed. Really? So I have to extend this thing and zero initialize m groups. Maybe before we call this, no. That's ridiculous, man. Yeah, well, that's like I mean, this might not be the best solution, but let's just run from somewhere to. Actually, this must be a group index. So we run from somewhere till the end. Groups I end. And I want to have a default constructed value, or value that is 0. Not even sure how that works. So we have a group. I guess the easiest thing is to just pass elements as a 0. Elements type is a bit set. How do I make a bit set that is all zeros? You cannot unless you call with a different bit set, or with a POD, or with a mask type, really. So we could pass a mask type that is 0. And this one is explicit. So we have to cast it to the mask type. Elements mask type. So bit set was elements type. Hey, Bear is back. Okay, I definitely did get confused here with elements type is a bit set, and bit set has a mask type. which is t, so that is the unsigned int, but okay, it's better this way. So elements type mask type is an unsigned int. We make that 0, and I can pass the mask type to the group. That seems unlikely. Elements type. Now I have to pass elements type to the group. But I can construct an elements type from that mask type. And then from that we can make a group, and then we have finally what we want. Yeah. I mean, initializing something to 0. Oops. Type 70 foot shot. And again, my left ear thing of the headphones turned off shortly. It's not good. G.I. Joe. So what do we start with? We would start with 0 if we did not have any groups. So this must be the size of the parameter pack. Isn't that like size of ... groups? I don't know. I mean, if it compiles, it probably was correct. Otherwise, I'll have to dig deeper. If it compiles. Now let's run vulkan again. That solved it. Okay. So then I can go back to, well, release with debug info is good enough. Let's keep that. Let's go back to elements.h. Element.h. Let's try 5 groups. Also works. Okay, so these were the 10 random partitions that we try, and then we walk up the hill to the top of the hill, and we always reach the top of the hill, apparently. From each of these 10 places we get to the same top, with the value 105. Here it says how many partitions got there, so all 10. 0 till 9 is 10. But we don't no longer need to print those starting positions. Let's remove that. Partitions. Oh, well, do I want to print RP? Not even that. Let's do 1000. 10,000 takes a really long time. Maybe I do want to print it. Let's see how long it takes. What happened? Oh, it's fast. Yeah, it's fast because n is low. Well, if we generate 1000, all of them always end at the right thing. So yeah, you have the perfect algorithm, except of course when you increase the number of elements to 6. I have a feeling. I look down and headphone fails. Oh yeah, at 6 it already fails. So this is the best solution is this one. And yeah, X32. I was reading your comment as you couldn't quit programming. You were just furious like me, you know. And your mother was calling X33. Come to dinner now! But you just couldn't quit typing because you were using Vim. That's how I interpreted it. For a millisecond, and then I understood what you meant. That's why I had to laugh. Right, okay, so the problem is then that this is the correct partition and we get stuck at this. And the reason is quite simple. I'm only trying to move one element at a time at the moment, or the whole group. So moving the whole group means of course moving it into another group. So that would be putting everything together. Putting everything together is not good because there is a minus infinity. And putting one element at a time is not going to end up with this. And C and F really need to stick together because that's worth 100. So we would find this one if we would move only a subset of the ACDF. Namely, the C and the F, or the A and the D. If you move the AD out of it, or if you move the CF out of it, then we would immediately find this one. But if this becomes a very long list, then that is Lucas asked, Carl, did you ever want to solve a coding problem but couldn't find a solution in the tutorials? I don't think coding problems have tutorials, so I do not understand your question. Normally, when I have a problem emerges from what I'm doing. If I'm lucky, I can find someone else who had the same problem and find their solution. But tutorials are not in the picture here. What I'm doing now, the best thing that I could find about it, and it wasn't even a good match, is this one, I think. Yeah, I started reading it on the stream, explaining what it all means, and I did get to I don't even think I got this far. But yeah, what I'm doing is indeed click partitioning polytope in an e-dimensional space, where e is the number of edges. Except that I think that whatever they did here is a lot of theory, not very practical. I don't know what they did. They should have given a program that I could run. So at some point I decided to just start doing my own thing. But that's about the only thing I could find. It really, there is no solution for this. It's not even possible. It has been proven that this particular problem cannot be solved in polynomial time. It's an NP complete. I guess NP stands for non-polynomial. I don't know. Or nasty problem is also possible. Right, so I could add another algorithm which just picks two elements and tries to move them. Which two? Well, we have ACDF. Why not look at... Well, that's already a lot of pairs, but maybe I can at least look at the pairs. I mean, let's say if I have a group with 14 elements and I have to split it up, then the subset that you can take out of that is some binomial or something like that. It's a huge number. But I can look at 14 times 13 divided by 2 pairs, of course. So just run over all the pairs. I mean, that's just this table. It fits in my memory. I can run over it. So that would mean that you could say this thing I can order. Let me copy everything to my scratch board. Okay, what happened? Well, for a moment I just lost my mouse. Insert? There's no insert. I'm apparently not... Oh, there we are. It's just this extremely huge file. Now I'm deleting it. I'm still deleting it. I'm still deleting it. I'm still deleting it. How big is this file? Yeah, there it is. Okay. Yeah. So if we want to split up this, I can make all the pairs that are in this group. And the existing pairs are AC, AD, AF, CD, CF, and DF. And the values are AC is 1. AD is 100, AF is 5, CD is -5, CF is 100, and DF is -5. Then I can sort that, more or less. So we get 100 at the top, 15 -5. That's all pretty doable. And then I could try to move CF out. If that fails, I can try to move AD out, etc. I have no idea. Toxicism. I never do in deadlines. Usually it's just suddenly finished. So CF. Well, if I do this, then I'm moving out pairs. But of course, also that might fail. So. I mean directed. Depends what do you want to put in the graph. I don't think there's any direction now. Okay, Lucas says, I mean like if ever tried. I'm not fixing your grammar again, okay? So I'm just reading what you typed now after you retyped it. I mean, like if ever tried to solve a coding problem by watching YouTube videos, but you didn't found the right solution. I hope you're not English natively. I don't think I ever watched a YouTube in order to solve a coding problem. I don't believe in YouTube's and learning from YouTube's. I like to watch YouTube for my amusement, and the amusement might entail learning something. But if I already have a problem, then I'm not going to watch a YouTube to understand how it works. Then I want to read something. And you can read at your own speed, etc. It's okay, man. I'm just... see, I cannot think of words. I'm just playing with you or something like that. What is the right expression? Harassing you? No. Definitely not right. Okay, well, anyway, trying to move out CF is a good idea because they kind of like to stick together. So it could work. In this case, it would work. Because then the first thing I would try would be CF or AD, depending on which gets at the top, and then we would indeed immediately find the answer. But let's try to find a case where moving a pair does not work. I'm not sure I can easily find that, but it's actually unlikely that you can find it with 6 elements. This is the same one. I don't think you have. No, it's not. Cannot be the same one. But it is. Of course, it's the same one. Why is it the same one? Because you have 6 elements. Or because this doesn't change. I want to wait to change. Zip. Whoa, 4 difference. Well, this is the solution, and when we are here, whoa, that one already does not work then. That is, we could try BF as a pair out of it, and then either include it with the D or put it on its own. But I'm not sure if the score will be higher than 208 in that case. Kanish, have you tried competitive programming? Tried. I thought maybe this is fun, so yeah, I started with it. I didn't like it, so very, very little. I solved, I mean, it's like, it felt like wasting time. Sometimes you can work an hour or 2 hours on a problem, and then you solve something that 300 other people already did. Why would I do that? I'd rather work on something that nobody ever did before. At least that I cannot find that I did. If I can find if I did it, I use what I did, but I cannot find it. So you have to move B. We have to. Oh, I think I have a trick here. I should not I mean, we are really stuck, right? I think my current algorithm is already pretty neat-ish. And yeah. I mean, I could throw moving a pair on top of it, maybe, yeah. Maybe I should try that. So just what I just said, if it gives a big improvement, why not? But then at some point, I think there's a better trick where I'm not looking for a better neighboring partition, but simply rip it apart partially and then run the algorithm on that. For example, if I would change this thing into, I would take B out of here and put B out of it, and I would also take yeah, it's not sure actually. And that's why it's an NP incomplete problem, isn't it? It's no good solution. Yeah, but well, I was thinking, what if I take a pair out of it and I do not put it back? I just leave it out, and then I run the algorithm, and then the algorithm is going to try to put that pair back into any group. So I don't have to try that myself. It's slightly more powerful, I think, because it could also try to combine. No, yeah, well, no, not really. I thought about something else before, that like if you have a lot of local maxima, then you could learn from it which pairs really want to be together. But as you can see, that doesn't work. For example, this is the answer. There's a score of 405, and we have 3 local maxima. From that, I could conclude that AB really wants to be together, because AB is together here and here and here, but it's the opposite. Since they are local maxima, I should look at AB not being together. It's like the trick question with the, well, that's actually, it happens for real. You know, I think it was in the Second World War, otherwise the first one, probably second, I don't know. Probably first one, I have no idea which one. But airplanes were sent out, I guess Second World War, and then the English people sent out airplanes, and then only half of them came back, and they were full of bullet holes. And then some guy said, like, well, we have to patch those. We have to patch the parts that have holes in it, make that part stronger. And then the smart guy said, what? No, you have to make the part that do not have holes in it stronger. And he was of course right, because if there is only holes at places, sorry, if there are no holes at certain places in all the planes that come back, then you can conclude that if a bullet hits it there, then the plane crashes and does not come back. I just had to think about that, seeing this. So all our failures have AB together. Therefore, maybe AB should not be put together. Let's make the number of elements larger. Because, oh yeah, It's really... What is happening? In the meantime, I have to figure out why my headset breaks. If I try with my hand, absolutely never it stops. The sound never drops away. But if I forget about it and I just move my head a little bit, then suddenly it drops away. So weird. But it has to do with movement. So I'm sure it's the cable. Just cannot reproduce it. Damn it. Okay, let's go to 8. That's pretty amazing, isn't it? All of them end up with the same thing. But not now, not this time. 308 is the best solution. The others are super close. Whoa. Pretty special. Yeah. Well, in this case, you could say A and H belong together, because that's true. But then again, they are super close to the actual solution. I don't know if that says anything. Now, most of the attempts end up not at the solution, not at the actual solution. I'm gonna make it way larger. Nah, let's add 2 more. When I compiled with optimization, it became slower. Now I know why, because those arrays were uninitialized, aka filled with a lot of values. So there is a chance that it is actually pretty fast now. Now I fixed that. It's still immediate. Although, well, we're not even close to 26 elements yet, of course. I think that in these cases, with the lowest count that reaches a certain local maximum, you can be pretty sure that we found the best solution. Unless, of course, say there is a better solution than this one, but absolutely no one can reach it. You just have to, by accident, generate the right partition to see it. Seems unlikely. Still super fast. Let's add more. I'm gonna go to 16. Still very fast. So now you see a lot of local maxima that are only reached from, by coincidence, by a single generated partition. So I randomly generate 1000 partitions, and then I run my algorithm on them, which shuffles the elements back and forward between the groups, trying to find a higher score. And there was only one that got stuck at this local. So the actual maximum, and that is 1290. Oh, I see it already here. Okay, that has 190. With this many, it would also be interesting to draw a graph of it, I guess. To get a feel of how these maxima are distributed. Do not seem to be very evenly distributed, which is kind of logical, I guess, because I only use very strange values, plus or minus 100 and then plus or minus 5. I mean, that's a big difference. Sorting the output would be nice as well. I'm having a map with results, and here's where I print them. So that would be printed. Oh, that's ordered by partition. Oh yeah. I'll have to copy them over to another map, I guess, to sort them by score. Let's make another map and then we use score as the key. And yeah, partition as the data. And just fill in the score. And we assign a partition. Yeah, I think that might not work. I mean, the certain partitions can have the same score, which then we would get lost. So we need a multi-map. So the same key can occur multiple times. And then the square brackets probably won't work anymore, so let's just use insert. And insert just uses a pair usually. So make a pair from the score and the partition. Yeah, I don't think I want to store the partition here. I want to store the an iterator to the previous map. Oops. So this is the type of the previous map, and now I'm just going to store iterator to that thing. Could be a const iterator, but and now we run over iterators here. Just auto whatever, some result iterator is results.begin. Result iterator is unequal results.end. Next iterator. And then we store. I need to get a partition, so we have the iterator, and that's the references to a pair, where the first one is the key, which is the partition. So first is the partition, and second is the number of random partitions that ended up there. And now we use the score as a key, and then I store the iterator. And then they are in the order that I want. So now we can run over all the elements, which is then say the score to partition iterator. Well, iterator. Yeah. I'm using an iterator as well. Now the score is simply a key. And first was the key. And then the second is is then this iterator here. So you can dereference that iterator to get a partition. So that's now the partition. While the same thing, but then second is this int. So that's the count. So this should print the same thing, but that then in the right order. And I did. So now we see this the score is in the order, and we even have two elements with the same score. Great. Okay. What I wanted to test again. Yeah, this count here. If that ever gets very low. It's maybe a good thing, or maybe even logical actually, that local maxima have a low count, because let's say if I have a good algorithm, that count would drop to 0. It would just always find the answer. So the lower this count, the better my algorithm. Now this one is pretty high, but still 1/6 of the actual answer. And here we have a 27, 57. So yeah, well, this one is the worst one. Let's run it a few times, see what happens. We have, ooh, that one only 42. And that one is really persistent. It's an ace in getting a local maxima. Pun intended, of course. Nobody's paying attention, I know it. But here's another ace. That's the first one. I'm almost not convinced that this is the actual solution. It remains scary. Okay, let's run it a few more times. 22. Whoa, this one's really low. $301, $308. He's got a big chance to miss it. 660 against 100. So only 1/6 of the starting partitions end up with the correct solution. But hey, we're still fast. Let's change my 1000 to 10,000, which was annoyingly slow before. This gives at least with a lot more certainty the correct answer. So now we really know that this is the answer, because it's really high. It can be 1/10 of a local maximum, which is very close, by the way. Let's see what difference. The chillimp is in both B2. The only difference is moving GK into there and then moving EJNO out of it. So I would have found this by or not. Let me see. Oh, my F is still here. Yeah, ADF. So I would have to move 3 out of it. So if I make an algorithm that moves 2 and or 3 out of it, just without looking at the score, I could move A, D and F out of it. That would leave me with E, J and O. And then it could move GK back into the ADF. That's algorithm that I already have. So it would find it if I just move 3 elements out of it. But 3 elements, I mean any 3 elements would already be, well, this is 7 elements, so 7 times 6 times 5 divided by 2. Possibilities to pick 3 elements. Still doable maybe, but is there no better way to find the ADF? A D is 100 score, a F is only 1. Okay, but it's positive. What was it now? ADF, yeah. So just AD is something, and then maybe DF. DF is also 100. Yeah. Okay, so together there are 201. That's a high score, and might be the highest score of unlikely. triplets. I guess one way to look for high triplets is simply sorting them by in some order and then running over it. In this case I would start at 100, of course. Let's say I look at K. I find 100, that's A, and then I find also here 100, which is G, and then we look at AG, which is -5. So that's not too bad. And then G has a 100 score with D. And DK is -100, so that's kind of a no, not interested. There'll be some kind of algorithm, I think, to find clustered elements. DAE. So D is only 100. It's not true. You have to go like down and then left. So these are all D. So I'm counting 1, 2, 3, 4, 5 100s. Oops, 5 100s for the D. Yeah, that's an idea. I guess I could look at the positive values and then add them all up for each element. If I would do that here, I would get. I have to copy it. Everything. So A has, ignoring the negative values, this one has 6, 7, 17, 22. That's not much. And then the C is, let's see, 100, 200, 205, 305, 405, 410, 415, 420. And D has 106, 206, 306, 406, 511. One, 116, yeah, 121, 226. You gotta wonder if can I not do this faster by writing it in code and then printing the values you want. Starting to wonder that myself too now. Not even sure anymore how I store this. Okay, I'll try to beat myself by doing this in code indeed. So we start with printing this table, which happens here, I think. Not. Yeah, this prints scores. Yeah, this prints scores. Eh, what? Yeah, this prints it. So here then I would have to add the sum, score sum, whatever. Let's see, this is a G scores thing is a factor of score. Can add that. Just call plus equals on it. How do I find this the score for a pair element? The score index is from a pair. And score index EP get pair. EP is an element pair. Right. So we just need to run over all the elements, as in again, this time using 2. And then I can add these scores. Oh, actually, I only want to add it if it is larger than 0. Okay, let's split it up. So I'm creating an element pair. Score index, and then we have a score. And I want to add that only if the score is positive. That means that it is not infinite or positive infinite. I guess. Could use this one maybe. Yeah, I can just compare it with a null score. Null score is a score that is a default constructed. So let's just make a score here. Python is just a language. Programming language. I have a friend who is a professional Python coder. I think he works on embedded things, I'm not sure. Well, it compiles. Let's run it. I don't think that worked. That prints a bunch of zeros. Definitely not what I wanted. And I've got a new line. Okay, why is this printing 0? We print score sum as if we never get here. That's a lot of falses. EP is A. I guess we have A and A together. Okay. Should not have done that. Actually, we should not even have... oh, we don't. Well, that's good. But the score is always 0. And I have a feeling I know why. Because I'm doing this before I assigned that bloody thing. How stupid can you be? It's being assigned here. It's being assigned while I print it. So I'm gonna have to copy this. Holy cow duplication. Maybe I should do it manually, those additions. No, I can print it at the bottom. Much better. So now we assigned it and now I can print it. And the opposite card cons pointer sip. I don't think it's all zeros anymore, but it's absolutely not no. Nobody knows what it's doing. So let's do not do this debug output anymore. Yeah, absolutely perfect, except not perfect. These things are way too wide to print below here. And I do not see the numbers that I had calculated. Well, I might have skipped the infinite. Oh, random numbers. Yeah. Oops. I did not use the same seed as before. So these numbers are going to be different every time. It kind of sucks because I thought that was a good example. You think we can still find that back? That was this one? No, I don't think so. This was the one. And this one started with the seed of that, and that's for these numbers. So I don't know why it's not printing the seed for the other random number. I'm also using random number to generate the partitions. It didn't print it, but I guess this should be enough. Random number. Yeah, see, now we get the same thing, the chilump and the EG and O. $322, 22, 420. I cannot remember to have calculated 511. I think I made a mistake. Anyway, this one is printed below the A. This one's printed below the B. I do have to check one of them. Let's check the 511. It's not shifted. Why would it be shifted? It's like that. The beginning of the number is at... No, it's not. Oh, this was printed knowing that the elements are one character. So instead I should use a width of 1, 2, 3, 4, 5 and no separator. If I was into memes, I would make a picture of this and then write under it if you use SEP and don't need it. Now it lines up neatly with the end. So the 511 belongs to the D here. Well, I'm counting 100, 105, 205, 305, 405, 410, 510, 511. I think we have proof that it is 100% correct. No errors whatsoever, because the 511 is correct. And unfortunately this one is way longer than 5 characters. But you cannot have everything. Okay, so now what? From this we could conclude that the highest values are of course then this L and the last one, which is P. And if we wanted to add another one, that would be L, P and D maybe. But D and P is minus 100 and D and L is plus 100. DL would be nice. Now we need more like LP, that is positive for both L and P. Nothing. I mean, there's no two 100s. Unless I need to go up here again. L and P. That's here. Well, that's not helping. Also not. I can prepare a table with all the pairs and all the triplets. And why not? All combinations of 4 things even. All sorted by score. Ready to go. Sorted by score, yeah. I think that's a good idea. It's really a one-time thing, and it's a matter of how many memory do I have, how far I want to go. How far do I want to go then? Why not 8? That's ridiculous. But it would fit, I think. 8. That's like 8 faculty, right? It still don't have enough light to calculate 8 faculty. 8. 40,000. Yeah, that would be a vector of 40,000-ish scores. It totally fits in memory, easily. So, let's do that, I guess. Just make a table of all the combinations of up to 8 elements. Oh, wait, it's not 2. It's not 8 faculty. It's 26 faculty in this case, divided by 8 faculty or something like that. Yeah. It's a binomial. That blows up. Let's restrict myself to the 4 then. That would still be pretty damn. That's like n to the power 4. Number of elements to the power 4-ish. Divided by 4 faculty though. No, I'm just going to do 3. I mean, at some point you just have to stop. 3 should always be possible. Bear, you can read that. Am I doing something wrong? Because all I see is absolutely unreadable, strange language. I do not see a translate this option. It's way too hard for YouTube, for Google. Google doesn't know how to add the translation to the chat. How would they? Those stupid company. It's not like they are making AIs and stuff like that. AIs that can understand all the languages in the world. Yeah, okay. But is there something that's built into your browser, or did you just copy paste it, Bear? The delay must be huge again. Right. Okay. I'm not missing anything then, I guess. I mean, in terms of YouTube configuration. Invis Infinity, yep. Okay, so what I want is to make a vector with vector. So a vector with groups. No, it's a map. The map? A map that maps, yeah, a map that maps groups to a score. Group to score. It's not really group, it's like the 2-3 groups. So I do not single elements. Single elements are in G scores, where the G stands for global, by the way. Oh, those are scores for pairs only. Those, of course. So then, but I can put them in this map as well. Yeah. So I'm going to make groups with 2 or 3 elements. So therefore, let's call this 2-3. Group 2-3 to score. And I want to fill it with do I want to look up the score for each group? No, I want to know. Wait a minute, what do I want? Probably do that. Vector would be so much faster. Going to need it all anyway, right? Index. Yes, like. Maybe, I don't know what I want. I guess I could start with this. And then maybe work it around later. Yeah. Okay, let's fill in the groups which are really pairs then. That's first. And I really don't think I should work with negative pairs. We can still do the same trick here. So here we have a pair, and then if it is a positive score, I'm going to... This whole sum is nonsense. I'm not doing that. So not printing it, not adding it. But we have a score here, which belongs to a certain group. And the group exists of these two elements. I have to construct a group, I guess, so I can just use group here. make a group from two elements which are constructed from the two element indexes. Yeah, I'm an idiot. I meant elements. This is nonsensical. Can I not OR the elements? Yeah, we have an OR here. I think it's more like that. OR together two elements and then a constructed group of that. And I want to do three elements as well. So after I've done this, I could do three elements. I mean the third element. But yeah, well, actually I do not want to do this, right? I want to begin at the ordering of the elements is not important. So I want to begin at I1 plus 1, which is not sure that possible, but element index is a bit set index. That probably works then. Index, and this bit set index. I have a plus that adds index, yeah, index and int, we can add it. And then here again, this is just I2 plus 1. We make two pairs, I1 with I3 and I2 with I3. And we need to get score index for both. So let's call this one EP13 and this one EP23. EP13 and again EP23. This one's 13 and 23. And then we get a score for both 13 and 23. And the score of the triplet is then I have to add that to the score. Already processed score, so I can just add it. Like that. Okay, I think that should work. And then afterwards, well, we are not printing anything. It said we were not printing anything. Let's start by looking if it still compiles. It compiles, it runs. Let's print what I just created here. This group two score thing. Do I have support for printing a map? I think so. It's probably not readable. DOD notice. Just print the damn map. Always curious if that works. Powerful, powerful. Well, that was our map. No, not readable. Oh, actually, it's not readable. Let me see. How not readable is it? So it says the NO has a score of 100. You can see that here. NO. Right. NO is 100. Yep. MO is 5. MO is 5. And then we get that MNO is also 5. M O is 5, and then NO was 100. Yep. And MN is minus 100. So yeah, the triplet NMO is these three values here added together. So that is also 5. Now here I see a nice one, is 276 for IJO. So I have to find the three values, I and J. That's 1. And I and O is minus 5, so now we are at 4. I'm never going to get to 267. Never. Not like that. What is this? IL minus 5. IO is minus 5. What? It's minus 10. I'm looking at ILO, that's not correct. I was looking for this one, IJO. IJ is 1 and O is minus 5, so it is minus 4. And then JO is 100, so that's 94. So it should be 94, but it isn't. Right. Yeah, nobody gets it, but it's not correct. Plus it's unreadable. Let me print it in a different way, like in a real way. I see the problem. I still want to print it. We can just run over all the elements. I can also print pairs, I think. So let's try print it like this. Still a bit nasty looking because it prints first and second, but okay. So the one that was failing was IJO, I think. IJO, yeah. Now it's 69, which is what I had calculated manually. So now I can sort this by score, and then we have to find back the groups, I guess. Let's see. Yeah. So those are the scores of pairs and triplets, which we're filling here as the score was P second becomes P first. Well, then let's print that as well, so we know that we didn't do something completely wrong. And S, run over all the score 2 3s, and I'm printing it. No match for operator. Oh yeah, that doesn't work for multi map. I can do a standard make pair here, or I can do try and place. I think that works as well. There's no member named try and place. Did you mean in place? Time to look up the documentation of standard multi-map. We have an insert and place a hint. Place argument. Talk about multi-map, right? So it's even a place uses make pair. Well, then I might as well use insert. Why does this thing not have try and place? Oh, because it never fails. Map has a try and place, but then the try means testing if the key already exists, but a multi-map can store the same key multiple times, so they don't have it. I think it's a miss, because now you have to use a standard make pair, which I think is ugly. Shall we place it? Nah, just insert. Standard make pair. Yeah, we had a pair and then we swapped the two elements, and then we make a pair again. Gotta wonder if it's not possible to do that any faster, but probably not, because they are different types. Okay, and as you can see, this is now the score is positive, and positive, yeah, larger than 0. And we have multiple keys that are the same, and it is ordered by score all the way up to infinity and beyond. So it's a minus 200, but we add infinity. It's larger than 300, just so you know it. Help has the highest score. The highest triplet with the highest score. Help here is a complete failure in comparison. I don't know, I'm digressing and or in need of going to bed, I guess. So what we're going to do now is that for a local maximum like this one, I'm going to run over the starting at the end here, the highest scores. So we're going to find HLP and then LMP and BLP and then so on, this direction. And I'm going to see if those occur in this set here. And that is a pure waste of CPU, of course. There's really not a better way. Depends on what is larger, I guess. If this is if there is only a few elements, it would be better to generate all the possible triplets, pairs and triplets that exist, and then look up the score. And if it's a huge group, then it would be better to just run over this whole thing here and see which exist. which by the way is extremely fast because I use bitmaps, so it's just a bitwise and a compare. But okay. Yeah, and then when I find one, I just put it in a different group and I run my algorithm again, and then if the score is higher, then we have succeeded. Otherwise, you take the next one. And then we would be really sad if it takes forever. If you don't find anything that is better, that would be, well, then we probably are at the maximum, right? I would like to see local maxima that escape this algorithm, but it's kind of slow. And I think that it's definitely going to happen, that they escape it as soon as we use a lot of elements. Maybe not this number of elements, but if we use more elements, definitely going to escape. In this case, I could also stop to 15, I think. So maybe do a compare. There are ones that are infinite. I'm not sure if that's relevant. Those infinites, by the way, are just just mean that I cannot accept an answer if the answer does not include all possible infinities. So they are not as important as you might think. Now I say that I would try minus 200 plus infinity before I would try plus 300. That puts a lot of importance on the infinity. Well, I guess that is exactly the importance that it has. I want to keep them together. Yeah. Oh, exactly. Yeah. If there is a plus infinity in this triplet, that means that there is a pair that I cannot rip apart. It's not allowed. What I should be doing is detect all the pairs that are plus infinity and collapse them into a single element, I think, in advance. AKA really there are less elements than there appear to be, because this plus infinity means that L and P are really the same element. They just must be always together. Doesn't make any sense to talk about plus infinity. I just should collapse these two. Only 3 days in and before I realized that. I'm trying to, yeah, GD Toki Infinity. I'm trying to make an algorithm that finds optimal clique partitioning. No, seriously. We have a number of characters, A through whatever, from the alphabet. And I partition them, so meaning, you know, you put some characters together and in a set and a few other characters together and so on. And then I want to find the best partition. And the best partition gives me the highest score, and the score is determined by inside each set for each pair. So that would be BL, BM, BPL, LM, LP and MP here. And a lot of pairs inside this one. I count the score from the table that I have. I have a table here. So CK is -5 and so on. So with that table, the best partitioning is this one. Put ADF, G and K together, B must be alone, these must be together, and A, G and O together. And then the pairs that these groups form each, their scores all summed up gives 1309 and 1 infinity. And the infinity comes from the fact that I put, where's my infinity? L and P. I put L and P together. Got stuck again. One, two, one. Okay. L and P are together, right? Yep, here. L and P are together. Now, because infinity is so important, L and P are always together in every local, and every local maxima. This is not a maximum, but it's a local maximum, because my algorithm, starting at this partition, finds so-called neighboring partitions, and each neighboring partition has a lower score. And the reason that every local partition has plus infinity is because... that's a good question. Yeah, of course, because there is only one infinity and no minus infinities. So it would always prefer to merge two groups together. Say if it was not LP, but it was FJ, and we had this, then we had not plus infinity, because F is here and J is here, and they are separate. Then I would just move over the whole group and put it into this one, so meshed everything together, simply because that gives us a plus infinity. So that's always just do that, and then from there I would maybe start removing elements again, but it would never take the F and the J apart again. And that's what I did for the L and the P here. But okay, that might lead to pretty large things. You know, the L and the P are such magnets that everything was thrown together here. And this is a bit too large. And then it has problems taking it apart again, because my algorithm only removes one element at a time. Either I mix two whole groups together, or I remove one single element. So it cannot go from here to there, because removing one element at a time is always going through a lower value. Valley. Yep. And that means, my friends, that yeah, I want to extend the algorithm by moving pairs and triplets outside of groups, instead of only one element at a time. But even that might not be enough. It would be better to somehow find elements that really belong together, even if it's a large group, and move those as a whole. Not sure how to do that yet though. I think I'm going to stop. It's almost 2 AM and I should go to bed-ish. So I'm such a problem going to bed. It's not funny anymore. But the music is good.